linear and non-linear relationship of the drug biological activity and its lipophilic properties. Okay. So we know that here it was first observed by Meyer and Overton theory. Okay, Meyer and Overton, what they postulated is the narcotic activity. That is the narcotic extent of that narcotic activity with the lipophilicity of the substances under investigation. So they actually observed the barbiturates. Okay, what are the narcotics? The barbiturates and other congeners. So exactly linear relationship is generally observed. There are many drugs, and all these drugs such as bacteriostatic drugs, bactericidal drugs, and also some drugs also that does not obey this linear property. So what are the specific characteristics of the drug that must show a proper linear relationship? So a proper linear relationship was shown by the drug binding with the plasma proteins. So blood contains many plasma proteins. So some of these drugs actually what they bind with the plasma proteins, and the exact relationship, the exact linear relationship was shown by such solid molecules. Okay. So here we know that the property of linear relationship was given by y equals to mx square. So where m is the slope of the relationship, that is tan theta value. Okay. Here we take the y-axis and x-axis. So a general equation for the linear relationship can be expressed by y equals to mx plus c. So if we substitute y equals to log 1 by c, log 1 by c, where c is the concentration, and if we substitute the slope value with a log p, then we get a relationship between concentration and the log p value. Okay, the concentration of the substances and the log p value. Okay, so here thus we can develop a relationship as log 1 by c equals to a log p plus a, where a is a constant. Okay, so all these type of relationship, linear relationships that is seen in the narcotics and bactericidal drugs, these relationships shows many points. Okay, it reflect many points that up to what extent a biological activity can be increased. If we increase the concentration of drug, up to what extent there must be an optimum up to which the biological activity will increase. Okay, but in real situation, what we observe that up to some extent the property, the biological activity and the relationship with the concentration shows linear relationship up to some point. Okay, beyond that point it decreases, just like it forms a parabolic curve. Okay, either it forms a parabolic curve or forms a non-linear relationship with the concentration. Okay, so in the next we will discuss about what is the non-linear relationship. So we will now discuss about the example of an anti-adrenergic drugs. Okay, we will take here the phenyl-amines. So phenyl-amine is, you can see here that the phenyl-amines have a structure of an aromatic structure. That is aromatic structure, they are mostly lipophilic. Okay, so here if we want to establish a linear relationship, we have to consider it multiparameter. Okay, so what is multiparameter linear relationship? Multiparameter linear relationship means we can consider it the Hans value along with the log p value and along with some delta values. Okay, so here we will take the logs p, that is the concentration parameter. We are also taking the Hans value and we are also taking delta. Okay, but the total whole relationship is linear. Okay, so there are different values. We here written as 1.15 plus minus, that is the error value. All these values may differ for different compounds, but the thing is that it is a multi-parameter linear relationship, and the relationship between the concentration and the lipophilicity will give us straight line. Okay, will represent a straight line. Now we will discuss about the non-linear relationship. Now we will discuss about the non-linear relationship between logP and biological activity. So we have observed that in linear model we have observed that the biological activity and lipophilicity, they maintain a straight line, okay, that maintain a linear relationship among them, and up to some extent we observe that lipophilicity and the linear relationship with biological activity along with the linear relationship, they are not infinite, okay, but we cannot extend it infinitely. So there are some point from where the increase in lipophilicity and increase in the concentration, they also is the actual lipophilic parameter, that is actual true optimum value of lipophilicity. It is far beyond that linear extension that we are talking about. So up to some extent that we can increase the biological activity by increasing concentration, but up to a certain point, up to attaining that optimum value, that is optimum value for the partition coefficient of a particular congener series of the compounds. So what is a congener series? Congener series means that congener series are the compounds that have the same pharmacophoric moiety, okay, that is the pharmacophoric moiety or the moiety responsible for the biological action is same whether the compound is developed, that is it is a higher version, it is higher congener series, it doesn't matter, it has the same pharmacophoric features. So now in that congeners we observe that the lipophilicity, the optimum value of the lipophilicity extends up to a particular optimum value. After that it starts declining, it forming a parabolic relationship. But why is this happening? The causes of non-linearity is the high lipophilicity of the drug molecule. So if the molecules need to be lipophilic, but not to some extent that it is highly lipophilic. If it occurs a highly lipophilic molecules, what happens that it tries to cling with the biological membranes. We know that biological membranes are lipid in nature and like attracts like, okay. So as the drug is also a highly lipophilic molecule and the biological membranes are also lipophilic, they start to cling together. And as they start to cling together, these molecules are very difficult to displace from that lipophilic membrane. So as it happens that they cannot cross the lipid membranes, that means they cannot cross the lipid membranes and enter another polar phase. Okay, so due to that reason, up to some extent, the lipophilicity is increasing. That is, the biological effect is increasing with the concentration, but after that it starts declining. That is, if we further increase the concentration, no lipophilicity will further occur because it produces a somewhat of saturation effect, what we know as the saturation effect, that is the lipid membrane that is filled with the, or that is completely blocked with the lipid molecules. And another feature is that micellar formation at higher concentration and a specific particular temperature also, that is also known as the critical micellar concentration, okay, or at the temperature, a particular temperature at which the micellar formation takes place. In that also, the drug, which is generally found as a monomeric form, they form dimers or oligomers. So when occurs that so it is untamed to displace, okay, untamed to displace through the membranes, and it also occurs that they also cannot cross the membrane. And also in case of hydrophobic interaction, in some drugs also we know that the hydrophobic interactions between the drug side chain, we have a particular pharmacophoric moiety, and along with that we have the different substituent group attached, and that hydrophobic substituents, they tend to interact with the apolar groups of a particular amino acids. Our body is full of amino acids. Everywhere the proteins basically they constitute amino acids. So these amino acid side chains, the apolar side chains, they usually interact with the drug moiety. So the hydrophobic interaction between the drug side chain and apolar amino acids, they are also the causes of the non-linearity. Okay, so these are all the parameters due to which the non-linearity is generally observed. Okay, in the next lecture we will discuss about the chromatographic parameters. Okay, in chromatographic parameters we will see different relationships, how we can describe, how we can derive the lipophilic by other parameters apart from the classical partition coefficient. Okay, thank you.